Okay, now we are gonna do the permanent magnet synchronous machine in a steady state. So in the last video, we figured out that this was the voltage in the stator. Here we have the equations for the voltage, the three-phase voltage and the three-phase currents. We have seen this before. So as we did in the squirrel cage, we are gonna say that our BS, that is our voltage in our uh, phasor form, is gonna be 3/2 m cos omega t plus j sine omega t. So this phasor is gonna be 3/2 Bm e j omega t. And if we do the same for our current phasor is gonna be 3/2 Im cos omega t minus theta plus j sine omega t. And here also minus the angle theta, the angle between the voltage and the current. So when we write this in our phasor, is also 3/2 Im e to the j omega t minus theta. Okay, so now we need to think in steady state. So we say in steady state. Okay, from here, when we are not worrying about the time, we are gonna have Im and we are gonna have e to the minus j theta. So we are gonna say that Is in steady state is Im e to the minus j theta, and our Bs is gonna be Bm. So our Bs in steady state is Bm. If we look at here, it's just Bm. So our equations is gonna be that Is 3/2 Is in steady state and omega t. Bs equals 3/2 RBs in steady state e omega t. Okay. And now if we go back to our voltage equation for that we figured out in the last video. Okay, it didn't want to copy here. Okay. And we're gonna change it now for our steady state representation of the voltage and the current. So we're gonna have this times R1 IS, and our IS is this, plus L1 the derivative of Is plus 3/2 L0 IF dt e to the j, and we have figured out before that E is equals to omega st. Omega st. All these omegas are omega s. Okay. Okay, so what we can look from here is that we have 3/2 in every side, so we can get rid of those terms. We have omega st in each term. Now here, the derivative of ej omega st is equals to j omega s e j omega st. So we are gonna have also an omega st here. So our function is gonna be in a steady state. We can get rid of this, so R1 IS plus, now the derivative is going to be j omega s L1 is plus j omega s, from here the derivative, j omega s L naught if. Okay, so this is our equation in voltage. Well, we have peak to peak. Now, in RMS, we just need to divide everything for square root 2. So it's going to be the same, but over square root 2. So this is square root 2 ps is equals to r1 square root 2. Now, we are going to call this is. So I'm just going to write it. This is going to be our xs is over square root 2, and this 2 over square root 2. Okay, so this is our equation in RMS. Now, remember that we have a permanent magnet in the rotor. So we're gonna say that this part over here is gonna be our no load voltage in RMS. So it's gonna be omega s or not over square root 2 times if. So this is also, we're gonna call EV, and this is an induced EMF depending of D on omega s. So the faster the current, the more the faster the frequency, the more EMF we get. So this is depending of speed. And we have synchronous reactance. That is our XS that we found here. Now, if we make the assumption that R1 is really small, so then our equation is going to be Bs equals to J AX IS plus EB. And our equivalent circuit is going to be an inductance here multiplying our IS. We are going to have our voltage, speed dependent voltage here, EV, and here is going to be our V1. Okay, so now we are gonna we're gonna try to figure out the power, but first we are gonna see this triangle. So here we have Vs in steady state. So we figure out that it had no angle, so it's just the real part. Here we're gonna have our Is that had the angle theta. So it's a magnitude and an angle. What is EV? Yeah, then we are gonna have our EV. Also, it's gonna have a magnitude and an angle, and we're gonna call it phi. So here we have our voltage equation. So if we have Vs minus EV, we are gonna get IGS. So this, okay, this is this vector right here. And now here we're gonna have a rectangle angle. So we know that the opposite from theta is gonna be sine, so the close one is gonna be cosine. So this side over here is gonna be s xs. That's what we figured out that omega js was. Uh, times the magnitude of is times cosine of theta. And if we look this as a big triangle right here, it goes all the way over here like this, then we know that the opposite of here is going to be the sine. So this is going to be EV times sine of the angle psi. So now we know that our power in is equals to 3Vs is cos of theta. And we know that xs times the magnitude of is cos of theta is equals to EB, the sine of sigma. Then we can say that magnitude of is cos of theta is equals to EB sine of sigma over x. So our power in is gonna be 3Vs times this. And this is where we're gonna call our electromechanical power if R1 is really small. That's the assumption that we have to remember to use this power. And finally, we are going to have that our developed torque is our power equation over omega s. And like this, we have both our equations of power and developed torque in our steady state for our permanent magnet synchronous machine.